Good morning, my friends. We start infrared and thermal testing. Though I have another video, just I am covering this book. See, that one is better, and this one for any small changes. Non-contact infrared and thermal testing (IR) technique are used to determine the temperature of a point or a surface. Infrared and thermal testing is a powerful predictive maintenance (PDM) method that is used in many non-destructive testing. You can predict the future problems or anything will happen in your future. So measurement setup, microwave testing, reflection, transmission, scattering, scanning a full-scale reinforced concrete column, equipment setup and use. Heat can be described as energy associated with random and chaotic motion of the atomic particles which compose matter. Temperature is a measure of intensity of particle motion in degrees centigrade or Fahrenheit, or absolute scale. These are relative scale. The relative is Celsius and Fahrenheit, and absolute scale is Kelvin and Rankine. Already described in the very good in previous video. Please have a look. Convection and conduction. Convection is thermal energy transfer through motion of fluids, which is dominant transfer mode for liquids and gases. For example, heat air rising as a result of its own density, while cooler air sinks. All matter with temperature greater than absolute zero, minus 273, 0 degrees Kelvin, emits thermal radiation. This is important. So just above 273 minus 273 degrees centigrade or 0 degrees Kelvin, all matters, anything greater, so it is emits thermal radiation. If it is just 0 degrees Kelvin, no, nothing. Emissivity and a blackbody radiation. Emissivity is the ratio of total energy radiated by specimen surface at a given temperature as compared with total energy radiated by blackbody radiator at the same temperature. So that is called emissivity. A hypothetical blackbody emits maximum radiation energy theoretical possible to given temperature. Consequently, it is the emissivity of 1. A blackbody would also absorb all incident radiation falling upon it. It will absorb all and then emit all. A real material has emissivity greater than 0.0 and less than 1.0. Contact and non-contact thermography. Contact thermography techniques are available for mapping the temperature distribution of area, possibly using the liquid crystal panel type that has been useful in medical appliances to screen patients of deep vein thrombosis. Non-contact IR techniques detect infrared wavelength or electromagnetic radiation emitted by test object. Non-contact techniques are useful for moving targets when a target is in a controlled environment. Pyrometers. So optical pyrometer, which is essentially automated, adjusted manually until the incandescent brightness of the electrical resistance heated filament matches that of a target within the same field of view. So there is a filament, you just match it. The color of the filament should match. The target must be temperature greater than 700 degrees centigrade so that you can see the color. Otherwise, below that, there is no color. And when the brightness of the filament and target matches, the filament disappears from the view. About disappears, so it is totally matching. So because of the human eye, is the detector and the eye must be protected. Only visible red wavelength are used in the comparative measurement. Other screens called photo screens can be used to control intensity of light allowed to reach the eye and increase the useful temperature range of the instrument. Electronics pyrometers are automatic and focus the thermal radiation from a source into detectors such as photocell, multiplier tube, thermopile, pyroelectric device, bolometer, arrays of detectors such as microbolometers. We change their electrical resistance and temperature are commonly used within the thermal imaging cameras. Passive and active. Passive means what your daily life. So passive imaging is solely observation, an image, the real-time mode of energy of a surface. Example, passive thermography application include observing the heat signature of a home and measuring the distribution of thermal energy on a recently landed aircraft. Means when heat is there already, full day sunshine is there. In the night you see the heat signature of the home. So you can find where is the damping, all these things, dampness and all. Aircraft, when water ingression is there in the honeycomb composite structure, when it is just landed, so you see the cold spot there because of ice formation in the high altitude. Damaged refractory on the inside of a boiler with screen temperature 465 degrees Kelvin. Photograph thermogram. So it is just a photograph and then the showing thermograph. What is the temperature difference and all. The passive thermography technique is the cost-effective and quite commonly applied. When applied under the umbrella of predictive maintenance, passive thermography applications are divided into two groups, electrical and mechanical. Resistance to electrical flow causes an increase in temperature, sometimes due to loose, corroded, undersized connection to so electrical components are common test objects. Four subsets: friction heating, valve leakage, blockage, insulation, interpretation. Building interpretation may be complex. So active means you are applying some heat. Active thermography doesn't rely on native thermal energy of the sample, but rather introduce heat with the external source. Once it is introduced, the sample's surface is then thermographically monitored. The localized temperature decrease in the time. Temperature differential, change of temperature over the time and related to heat transfer characteristics. Rate of heat flow away from the test surface is altered by discontinuities and subsurface symmetry. External heat sources vary widely but include hair dryers, glass lamps, infrared light emitting diodes, lasers, introduction heating of induction heating coils. All this. So one side heating and you can see from other side or same side what you want to see. So if you see same side, there is a big lamination. So you see there is a bright spot on the same side. If you see from the bright means heat spot from there is in the lamination. But when you see from the back side or other side, you can see a cold spot because of lamination. So that is the difference, not much. Vibration thermography, vibrothermography. Heat generation may caused by some combination of friction, plasticity, viscoelastic losses. Vibration causes by high power acoustic waves can cause the opposite phases of discontinuity, such as delamination of crack to vibrate against one another, like rubbing your hands together. The friction causes heat sample are thermographically monitored during vibrothermographic inspection for telltale heat signature of the cracks during the acoustic excitation. The advantages and limitation: measurement devices may be contact or non-contact techniques are passive or active. Essentially, any type of material may be evaluated With infrared and thermal testing techniques, inspection result can be immediate. Interpretation of these results are straightforward. The IR method is safe as no harmful radiation is involved. The techniques may be chemical free. However, material with low emissivity generally requires a coating of some type, reduce measurement error and reflections, black tape or some water-based paint, black paint. Measurement error may be significant when observing a sample with varying emissivity. Acoustic emission testing. For this also I have one video. You can see that this is just extra, anything is there in this book. Instrumentation, acoustic emission. A instrumentation is designated to detect the structure-borne sound generated by source. The signals from one or more sensors are amplified, measured to produce data for display and interpretation, and the array of AE detectors may be used to detect and then triangulate the source. Sources of signals. Acoustic signal source include crack initiation in surface mill scale, crack tip welding, crack extension, certain phase changes, or growth in the microstructural phase, turbulent flow, or leakage, boiling, chemical reaction, friction or fitting. Impact, matrix cracking, delamination, active corrosion, matrix disbonding, and fiber breakage. Application method. Detection of discontinuities and detection of leaks. Discontinuity detection monitoring and simple or transient short-lived burst signals, while leak detection is concerned with signals of larger duration in both the cases. Transient. So AE waves are produced by application, sometimes relaxation. AE test may monitor the object over time, and short-term tests can be performed while applying control loads such as proof load, fatigue testing, hydrostatic pressure test, or creep test. Some material emit AE signals upon loading, but once the given load has been applied and the acoustic emission from the accommodating that stress is ceased, the additional acoustic emission will not occur until that stress level is exceeded, even if the load is completely removed and then reapplied. The same load is applied, reapplied, you get nothing. This is the known as Kaiser effect. So A technique for leak detection are based on its principle that the flow of fluid, the caused by pressure differential changes from laminar to turbulent as it passes through the orifice. Comparison with LTE and BA, the technique of acoustic leak testing is closely related to acoustic emission for leak detection. Okay, we'll stop here and we start for another